Let's place a water duck on the water and make some observations. What observations can you make about the movement of the duck? The duck moves up and down, while the ripples move in a linear direction. Now, let's explain our observations. When you hit the table vibrates and this energy is transferred to the water container. This energy is then transferred across the water, however, the water does not flow across the water dish. The water simply moves up and down, hence the movement of the duck in the up and down motion. The up and down movement of the water results into wave effect. To clearly understand how the up and down motion can cause the wave effect, we are going to use 4 groups of students seated in rows. The first group of students will stand first. As it sits down, the second group will stand. And as the second group sits, the third group stands, and so on. You will notice that as different groups stand and sit down, we get a wave effect. The standing and sitting is similar to the up and down movement of particles in a medium like air, liquid and solids. Now that we know that as energy is transferred through a medium, it causes up and down movement of particles resulting into a wave effect, let's define a wave. A wave is a disturbance through a medium that transfers energy from one region to another without causing permanent displacement of the particles in a medium. There are 2 types of waves. The first type of waves are waves in a string or water known as transverse waves, and the second type of waves is longitudinal waves found in sound. We are going to use a spring to demonstrate the difference between the transverse and longitudinal waves. Let us first mark a point on the spring and then move the spring side to side to generate transverse waves. What observation can you make about the motion of the marked point and the motion of the wave? The wave is moving in the eastern direction, whereas the marked point is moving up and down. When you draw a line to represent the motion of the wave and also a line to represent the motion of the marked point, you will notice that the up and down movement is perpendicular to the direction of travel. A transverse wave is a wave in which the particles of the medium vibrate perpendicular to the direction of propagation of the wave. To generate longitudinal waves, we move the coil back and forth. The marked point in this case moves in the same direction as the wave. A longitudinal wave is a wave in which the particles of the medium vibrate parallel to the direction of propagation of the wave. Finally, let's use this rope to understand some key features of waves. Waves are made of crests and troughs. The peaks are referred to as the crests, while the bumps at the bottom are referred to as troughs. When we move this spring from the rest position, the distance between the initial position of the marked point and the final position of the marked point is referred to as amplitude. Amplitude is the maximum displacement of a wave particle from the rest position. The wavelength is the distance between 2 successive particles that are in phase. The wavelength is also the distance from crest to crest or from trough to trough. This is our complete cycle of oscillation, and the time taken to complete this oscillation is referred to as a period. Period is the time taken by a wave to complete one cycle of oscillation. Frequency is the number of complete waves to pass a point in a second.